Hey everybody, good morning, good afternoon, whatever time it is when you watch this. Just wanted to say hello, hope everything is well. As always, when I start my video, I wish I was there with you. I have class until 8 o'clock tonight, and I'd much rather be with you guys. But it's almost the next best thing. It's a video of me, so hopefully you guys are ready to learn. What you'll need is you'll need the same notes as that big packet we've been working on all week. But we're going to go over the graph part and a few more practice word problems, all using the same formula, the Fundamental Theorem of Calculus. So if you haven't taken it out already, maybe you could pause me, but I want you to take out your notes and go find this picture that you see up on the screen. So in the past, and I could scroll up to what we've been doing, we've been working off this formula forever, basically. Essentially, the first fundamental theorem of calculus, which I'll tell you every day, is if I take the integral of a derivative, it gives me the function across the bigger number minus the one of the smaller numbers. So as easy as it sounds, to get the actual function, I have to take the antiderivative of the derivative. Okay, but how does that look like if we did graphs? So we did a whole bunch of practice yesterday, but here's a graph, and it says the graph of f prime, or the graph, this is the derivative of f, is shown in the figure above. If f of 1 equals 5, then find the following. And it says, let's do f of 5. So first thing I'm going to do is I'm going to write out the formula. So you see how they give us f of 1 equals 5, and we're trying to find f of 5. So if I have f of 1 and I want f of 5, you know that your integral is going to be from from 1 to 5. This always is f prime of x. You'll notice because this is a graph, I don't have an actual equation to integrate. And then on the left side, on the right side, I get f of 5 minus f of 1. So hopefully I'm not going too fast for you. I know, Sequoia, I know this is a little bit fast to catch up on, but hopefully you could follow along. So that's my formula. It's the formula I've been working on forever. You know f of 5 is what we're looking for, so you know this is x. And you know f of 1 is 5, so I know that I can fill that out. Question is, what do I do here? And the problem is that I don't have a function to integrate, so how do I figure this out? Well, remember this, and this is what we learned, remember with the rectangles and the trapezoids and all that stuff. This sign means the area under the curve. And from 1 to 5, this is what I want. I want the area under the curve from 1 to 5. So basically I want to know, here I'll use a different color, I want to know the area right here. Okay? So the problem is I can't use, I can't use trapezoids, I can't use rectangles. I want the most exact one. So what I'm going to do is I'm going to try to measure this. Let me throw this away. Let me try to find this area. Okay. Well, you'll notice, and some of you did this when we did our exercise last time, you see how this is technically like one big box, right? So what I'm going to do is I'm going to take the measurement of this box, this rectangular box, and subtract this half of a circle, right? Would you agree the area of this box is 3 high and it's 5 across? So the area of the box is 15. And then I want to subtract the area of this little circle thing because then I'll get the area of this. So the box minus this half circle gives me the area under the curve. So the area of this circle, the area of a circle is pi r squared. So I'm going to say half of pi r squared, right? And I want to subtract half of the circle. And what do you see, what do you notice about the circle? What do you notice about the radius of the circle? Well, since the center is at 3, and it goes all the way to 1, like 1 to 3, and it goes from 3 to 5, you know the radius is 2. So now this becomes 15 minus half pi, and since the radius is 2, 2 squared is 4. I know y'all are bright enough to do the math, but this is 15 minus 2 pi. And that can't be simplified anymore. That's the area under the curve. This area is 15, the box, minus 2 pi. So this is 15 minus 2 pi. And, when we did rectangles and trapezoids, and this is just something I like to do, I like to put the area here and then, just circle it. Alright, so that means back to my formula, this whole thing, the integral from 1 to 5 of f prime of x, this whole thing equals 15 minus 2 pi. So now all I have to do is solve for x. Again, this is just algebra. All I have to do is add 5 to this side. So x, is 20 minus 2 pi. Here, I'll write it over here. How about this? I'll type it. 20 minus 2 pi equals x. So that is f of 5, even though I have no idea what the function is, even though I have no picture of f of 5, I can figure it out because of the fundamental theorem of calculus. Let's try f of 0. So f of 0, if I could delete everything. So let me just delete everything. Oh well, good enough. Alright, so looking at this, I noticed that it says f of 0. So remember, same thing, same formula. They give me f of 1, so I'm going from 0 to 1. F prime of x. And we're just going to shorten this because I think you guys are tired of doing this over and over again. You know that I'm looking for f of 0. Oh, sorry. F of 1 minus f of 0. So you may notice that this one's a little bit flipped. Usually I have this one as x and then this one I don't have. So now I'm actually sort of flipping it a little bit. F of 1 they gave me is 5. F of 0 is what we're trying to figure out. Alright. Now I want the area from 0 to 1. If I look at this, can you tell, I know you get mad at me for asking questions even though I can't hear you, but can you tell from 0 to 1 what shape I have under the curve? Yeah, it's a triangle. So this right here is a triangle. So remember the area of a triangle is half base times height. For this triangle, my base is 1 and my height is 3. So the whole area under the curve, half times 1 times 3, is 3 over 2. So back to my formula, this whole thing just becomes 3 over 2. And what I'm going to do to simplify is I will subtract 5. You know, with a common denominator, subtracting 5 would be like subtracting 10 over 2. Or this becomes negative 7 over 2. I know this is getting tiny. Equals negative x. Or x equals 7 over 2. Alright? So if negative 7 over 2 equals negative x, positive 7 over 2 equals positive x. I want you guys in the rest of the class to practice these graphing ones. Okay? Now let's practice some word ones. Again, all of this is the same thing, fundamental theorem of calculus, but whether it's a graph, a story, a picture, I want you guys to feel comfortable using the fundamental theorem of calculus. So let's jump down. You know, in the notes, the last one we did was this one. I'm slowing down so that you guys can follow. But let's look at the next one. This one's a little bit more difficult. So some of you say like this is easy. Does it get more difficult? Obvious answer is yes. So this question says the rate of change of the altitude of a hot air balloon. So you got a hot air balloon and it's in the air, and its altitude or its height is changing at r of t equals t squared minus 4t plus 3 from 0 to 7. Determine the change in altitude of the balloon during the time the altitude is decreasing. So the biggest mistake that people will make is they see this 0 to 7 and they'll do this. Right? And I don't blame you, it has a number, so everybody will probably want to do this for the fundamental theorem of calculus. So I want the change of altitude, so I want to, between 0 and 7. From 0 to 7 of f prime of x. See how it says the rate of change? So you know that this is the formula that goes here. But the problem is it doesn't say determine the change in altitude from 0 to 7. It says determine the change in altitude of the balloon when the altitude is decreasing. So we're going to look back at some, we're going to review back at some something that you learned last semester and see if you remember it. Before I can figure out, so this is wrong. So before I even figure out what number, or it's not 0 to 7, to figure out what numbers these should be, I need to figure out when is the altitude decreasing. Alright, to figure out when altitude is decreasing. So this one says rate of change. So do you see how this is my derivative function? So it might be a review for some of you, but to figure out where something is increasing and decreasing, remember I take the derivative, which they already give me, and if you might remember, I take the derivative and set it equal to 0. Does this sound familiar? Hopefully hopefully. Then I factor. T minus 4, t plus 3, you know this factors to t plus 4 and t minus 1. And that word that you might have forgotten is critical numbers. My critical numbers are negative 4, right? If these two multiply to give me 0, t has to be either negative 4 or t has to be positive 1. So what I found is that these are the critical numbers on my number line. Here's the problem. All I care about is between 0 to 7. Like, I don't care if this hot air balloon in negative time what it amounts to. So all I really care about, you know, again, I'm going from 0 to 7, is 1 and 7. Oh, sorry, and 0. So from 0 to 7, I only have one critical number, which is 1. So I need to figure out where is this altitude decreasing. So what I do, remember I test numbers. You should remember what's the easiest number to test between 0 and 1. I would say, I mean, you can pick any number you want. I'll say 0.5. And the easiest number to test between 1 and 7, I'll say is 2. Remember I take these numbers and I plug them into my derivative. My derivative, you can plug it into the derivative, or you can plug it into it factored. Remember, it factored makes it a lot easier. So you notice if I plug in 0.5 here, I'm going to get a positive. If I plug in 0.5 here, I'll get a positive. Sorry, I'll get a negative. 0.5 minus 1 is negative 0.5. So I get a positive and a negative, which makes this whole section negative. When I plug in 2, 2 plus 4 is positive, 2 minus 1 is positive. This segment is positive times a positive, which means this whole segment is positive. So when the question asks, determine the change in altitude when the altitude is decreasing, it's not 0 to 7 because it's not decreasing 0 to 7. It's only decreasing from 0 to 1. So instead of writing the problem like this, what I should do is write the problem like this, only from 0 to 1. Okay. And see how it says determine the change in altitude? So I'm not finding f of 1. I'm not finding f of 0. I'm finding this whole quantity. I want to know what this whole thing is, right? It says I want the change in altitude. So I'm not looking for f of 1 minus f of 0. I mean, technically I'm finding f of 1 minus f of 0. But that whole thing is what I'm looking for. So instead of calling this x or calling this x, I'm going to call the whole thing x and solve for it. I want to go through the algebra. I don't want to go through the algebra and take up your time, but you know that you're going to take the antiderivative of this, plug in 1, plug in 0, subtract it, and that's going to be your answer. So go through the algebra. And the last word problem I want to do for you, it says a pizza, I know. You should say, let's learn with the pizza. Maybe. But here it says a pizza heated to a temperature of 400 degrees Fahrenheit is taken out of an oven and placed in a 75-degree room at time t equals 0 minutes. The temperature of the pizza is changing at a rate of negative 3 radical t degrees Fahrenheit per minute. That's weird. Oh. So the nearest degree, what is the temperature at time t equals 4 minutes? So essentially what I'm trying to find out is, the temperature of the pizza at 4 minutes. For some reason, my cursor disappeared. But anyway, so I'm just gonna set it up for you. So you see, it starts at 0 minutes and it ends at 4 minutes. So I'm going to do the integral. Oops. I don't know where my cursor's gone. From 0 to 4. So I have no idea where I'm writing. See, my function is negative 3 radical t. Oh, forget it. You know what? We'll finish this on the next video. I'll finish it tomorrow. Can't see my cursor. This is terrible. Alright. I only have a minute left in the video, so for the rest of the class, what I want you to do is, I'm going to give you basically a copy of the worksheet that you had yesterday, but all I want you to do is the graph, and then a couple word problems that are similar to the one we just did. So, thank you for watching. I'll see y'all tomorrow in video format. Alright, take care.